Refraction at curved surface. For refraction to take place, there must be two media. When a ray of light passes from rarer medium to denser medium, the refracted ray bent towards the normal. And if it is passing from denser to rarer, the refracted ray bent away from the normal. Let us see how refraction takes place when the surface of separation between two media is a curved surface. Let this be the curved surface x dashed, which separate the media 1 and 2. Medium 1 is the rarer medium and medium 2 is the denser medium. So let us consider an object which is placed on the principal axis of this curved surface. The ray which is passing along the principal axis goes without any refraction. No refraction takes place to the ray which is through the principal axis because the ray is falling normal to the surface of separation between the two media. Another ray, so this is the object, another ray which passes obliquely to the surface of separation is represented by OA. Let this be the geometric center of the curved surface. We will name it as G. If we draw the normal to the surface of separation at the point of incidence, the normal meet the principal axis at the position C, which is termed as center of curvature. When the ray passes from rarer to denser, the refracted ray bent towards the normal, represented by AI. Wherever the refracted rays meet, the image is produced. So O is the object and I is the image formed by it. Since AI is the refracted ray, we need to indicate with arrow. The arrow is indicating the direction in which refracted ray passes. What about the angle of incidence? It is the angle between incident ray and normal. Let us name it as I. The refracted angle is angle between normal and refracted ray, represented by R. Let AOG is alpha, ACG is beta, AIG is gamma. We draw one normal from A to the principal axis. The normal meet the principal axis at position G dashed. Here we take the aperture, that is the lateral size of the surface, to be small compared to the other distances, so that small angle approximation can be made. So G and G dash are close by, or the distance between G dash is negligible, or the point G dash is considered to be at G itself. Now what is the angle of incidence I in terms of alpha and beta? Let us consider the triangle OAC. From the triangle, I is the external angle, alpha and beta are the internal opposite angles. So I equal to alpha plus beta. Let us write this as equation number 1. Now if we consider the triangle CAI, from triangle CAI, external angle is beta, internal opposite angles are R and gamma. So beta is equal to R plus gamma. So what is R from this? R is equal to beta minus gamma. Let this be equation number 2. According to Snell's law, the ratio of sine of angle of incidence to sine of angle of refraction is equal to refractive index of the medium to which refraction takes place to that of the medium where the incident ray passes. So sin I by sin R is equal to N2 by N1. If we take small angle approximation, angle I is approximately equal to 0. That is a very small angle that is nearly equal to 0. Therefore, angle R is also nearly equal to 0. So in such condition, sin I is approximately equal to angle I, which is equal to tan I. Similarly, sin R is approximately equal to angle R, which is approximately equal to tangent of R. So instead of sin I and sin R, let us represent in terms of tan. So tan I divided by tan R is equal to N2 by N1. Now what is tan I and tan R? From triangle OAC, we had seen I is equal to alpha plus beta. So tan I is tangent of alpha plus beta divided by tan R. Angle R is equal to beta minus gamma. So tan R is tangent of beta minus gamma equal to N2 by N1. Let us approximate tan alpha plus beta as tan alpha plus tan beta. Similarly, tan beta minus gamma is written as tan beta minus tan gamma. That is equal to N2 by N1. Now from the figure, what is tan alpha? G and G dash are same. So tan alpha is AG or AG dashed by GO or G dash O. G and G are same. So tan alpha is AG by GO. Let us write tan alpha is equal to AG by GO. What about a tan beta? tan beta from the figure is, if we consider this triangle, AG divided by GC. So tan beta is AG by GC. What about tan gamma? Tan gamma is AG by GI. Tan gamma is AG divided by GI. Now let us see what is GO, GC and GI. GO is the object distance which is measured towards the left of the optic center. So that is negative U, object distance U, minus U. GO is minus U. GI, image distance towards the positive x direction. So GO is plus V. GC is the radius of curvature R. So GO can be written as minus U, which is AG divided by minus U, AG divided by GC, radius of curvature, and tan gamma is AG divided by GI, which is plus V. Substituting these values in this equation, AG by GO plus GO can be written as minus U. So we write directly as minus U plus tan beta AG by R whole divided by tan beta again AG divided by R minus tan gamma AG divided by V, that is equal to N2 by N1. Now what about AG in all these cases? AG get cancelled out, numerator and denominator. So the equation is minus 1 by U plus 1 by R whole divided by 1 by R minus 1 by V equal to N2 by N1. For this equation, on cross multiplication, we write N2 into 1 by R minus 1 by V is equal to N1 into 1 by R minus 1 by U. If we take R terms to one side, N2 into 1 by R minus N1 into 1 by R equal to N1 by minus U minus N1 by U minus N2 by V. When it comes to the right side, it is plus N2 by V. That is N2 minus N1 into 1 by R is equal to N2 by V minus N1 by U, which is the equation for refraction at convex surface.